Okay, so I've got my function set up here. I've got a quadratic trinomial in the numerator, and I have a quadratic trinomial in the denominator. I want to create an accurate sketch of what this graph looks like, identifying its domain, all of its intercepts, and then the different pieces to the function. First of all, as far as finding the domain is concerned, we always ask ourselves what can't happen. And in a fraction, we can't have the denominator equal to 0. So we set our denominator equal to 0, this quadratic. Finding zeros of a polynomial is what we've been spending the last week on. You could graph this function individually and find its intercepts. That's okay. Personally, though, I hope you are capable of factoring this quadratic down into its binomials. Okay, we've got x plus 5 and x minus 4 as our two binomial factors. The zeros coming from there then would be -5 and +4, which is telling us right now my domain would be stretching from -infinity to -5, not including -5, until I get to 4, but I can't include 4, and I'm running out of room, but I got it in there. So here's us excluding -5 and excluding 4 from a domain of all real numbers. Okay. Graphically speaking, what these are for us right now, since they are values of x that we cannot include in our function, they are vertical asymptotes. So we go to where x equals -5, and we go to where x equals 4, and we draw our vertical asymptotes. The horizontal asymptote, when we are identifying the horizontal asymptote, we are looking for the degrees of the numerator and denominator. In this instance, the degrees are exactly the same. So our horizontal asymptote is the ratio of leading coefficients. In this case, 1/1, which is 1. So we have our horizontal asymptote at y equals 1. So identify our zeros. The zeros of a function are values of x that yield a value of 0 for the function. And if our function is a fraction, as it is here, the only way a fraction can equal 0 is if the numerator equals 0. So our x-intercepts are the zeros of the numerator. Again, we're relying on our factoring capabilities here. But again, like I said before, if you put this into your calculator and identify the intercepts of that piece, you'll know the zeros of this part of the function. If you trust your factoring skills, you would get x minus 5 and x plus 2 equaling 0. Therefore, x equals 5 and -2 as the zeros for this function. So where x equals 5 and where x equals -2, we have our 0. From this point forward, if you want to graph this function accurately, you've got to pick values of x and find their resulting value within the function. Here's what I will tell you. How many asymptotes do you see? You see 2 vertical asymptotes and 1 horizontal asymptote. That's 3 asymptotes, which means there are 3 pieces to this function. One piece of the function is going to occur on this side of that asymptote. The second piece to the function is going to be between the 2 asymptotes, and the third piece to the function is going to be on this side. Now, whether it's above or below the horizontal asymptote, that's up to you to find. So what you're doing is you're picking 3 x's in here, pick 2 more x's in here. Since we already have the 0, we want to know 2 other points to give us an idea of what this function is going to look like. And then we want to pick, since I've got the 0 here as well on this side, we want to pick 2 more values of x to plug into the function. You're on your own with that, but if you plot those points correctly and you exhibit the asymptotic behavior that we discussed in class, then everything should work out fine. Come to class with any questions that you might have tomorrow.